In this video, we will be looking at sets, usually sets of numbers. Remember, numbers can be used for identification or also for counting, in which case they are called cardinal numbers. Or if we're looking at their position on a number line, then they're ordinal numbers. We already discussed the natural numbers. So here is the natural numbers. Now, this is an example of an infinite set, because it carries on and on and on, it never stops. If we take the set A, which just has elements 2, 3, 4, then this will be a finite set, and the number of elements in A, 1, 2, 3, which in some books is written like this. Now, two new pieces of information, I think. If you have a set 2, 4, 3, this is exactly the same as the set 2, 3, 4. So in this case, A and B are equal. So with sets, the order of elements does not matter. In the same way, we do not have repeats. So we would not have a set like this, because this actually is the same as 2, 3, 4. So in fact, this is also, C is also the same. So C is the same as B, and that's the same as A. Now we've got two new sets, the set A and the set B. So I'm going to start with a Venn diagram. So I'll have A like this, and B will be like this. So in A I'll have 0, 1, 2, 3, and then B I'll have 4 and 5. Now, if we want the union of these two sets, which is written like this, U for union, then the union of these two sets, union everything together, so it's 0, 1, 2, 3, 4, 5. So it's everything that's in A together with everything that's in B. The intersection is what they have in common. So in this case, the intersection of A and B is the set with nothing in it. And we have a fancy symbol for this, of course, which looks like this. Okay. Right, let me show another set. There we go. Or another two sets. So let's look at set C and set D, and you can see I've made these up so that they do have an intersection this time. So if I have C like this, I must have an intersection, because 5 is in both C and D. So it has to be like that. Then I can fill in the rest of C, 3 and 4, and the rest of D, 5, 6, 7. So if you want C union D, then we will have 3, 4, 5, 6, and 7. If we want the intersection, C intersection D, this time the intersection will be the set with 5 in it. And then my last example on this page. Now what I've done is I've made sure that these two numbers are also in here. So in fact my Venn diagram would look like this. I'll have F here with 5 and 6, and then E needs to be something like this, because I've already got 5 and 6, so then I'll need 4 and 7. So when we have a situation like this, where everything in F is part of E, we say that F is a subset of E. And there's our symbol for subset. Subset. Okay, let's just check if we've got Venn diagram. Yes, union, we know, intersection. Universal set. We will usually put a big box around, or shapes like this, and then this big box will dictate the numbers we are talking about. So maybe in this case we were talking about, say we're talking about whole numbers. So outside here will be all of the whole numbers which are not in E. So that'll be 0, 1, 2, 3, I've got 4, 5, 6, 7, then it's got 8, and then so on and so on. Now, when we have this big box here, called the universal set, in some books you'll see a funky E, in some books you'll see a U, and in some books it'll be called a sample set, with an S like that. Let's say we take the set X, and it's got two elements, the elements being A and B. Now let's write down all the subsets of X. Well, you can have A, you can have B, you can have AB, and you can have the empty set. So there are in fact 4 subsets of the set X. These two are called proper subsets, and we will use this symbol. If we are using the set itself or the empty set, these are not proper subsets, but we can always include them as the subsets. So strictly speaking, if you're referring to all the subsets, you'll write it like that, because you're going to include the set itself. But you're going to say something like the set B is a proper subset of X. Okay. Let's talk about set builder notation. You see it at the top there. So set builder is just a way of saying things. So say you've got something like this. Like that. Then what that means is the set of natural numbers. That's what it means. And you'd read this as X such that X is an element of the natural numbers. So this is the set X such that X is a natural number. Okay, lastly on this page, one-to-one correspondence. Let's say you've got, you remember these funky things from primary school, 1, 2, 3, these function machines. And let's say our operation is add 1. Then 1 would go on to 2, and 2 will go on to 3, and 3 will go on to 4. And this is an example of a one-to-one correspondence, because for every element in this set here, it corresponds to a unique one in the other set. If we're talking about equivalent sets, what we mean is they've got the same number of elements. So this set and this set are equivalent. They're obviously not equal because they're different, but they do have the same number of elements. Subsets we've dealt with, proper subsets. Complement is everything that's not in a set. So say we have our universal set and A looks like that, then everything that's not in A, let me shade it like that, this is a complement. Okay, these two last things. The difference. If you've got the set 3, 4, 5 and the set 5, 6, 7, 8, then if you want the difference between these two sets, it's everything that's in this one which is not in that one. So let's see, is there anything in here which is in here? Yes, it's the 5. So in this case we're going to have the set with 2 elements, 3, 4. And the last thing, say you've got the set 2, 7 and the set 3, 4, 10, and you want the Cartesian product. It's the set of all the ordered pairs that you can make from these two sets. So it's the ordered pair 2, 3. And then we can have 2 with 4 and 2 with 10. 2 with 4 and 2 with 10. Then we can do the same with 7. So we can have 7 with 3, 7 with 4, and 7 with 10. Okay, so we need a semicolon there. Fine. Okay, remember to always use your curly brackets for sets, not this kind of bracket or this kind. No. Okay, so all that you need to do now, get hold of your textbook. Problem set A, page 51. Enjoy.